Sound test.
Hi.
Hi,
Long time no see.
and I am happy you are back.
I'm happy I'm back too. So, today we are in summer, July, and today officially was the hottest day of this year, 35 degrees. So, people were sweating, disappearing, evaporating, and so on. But you as a scientist today, let's discuss something or give the options how to cool down. I think that can be a cool topic.
And today we are speaking about the coolest liquid in the world.
Oh, nice. But let's start with options. Give me some options that are...
The easiest option is to go to the refrigerator.
Yeah, it sounds okay. But it's not that cool. It can be minus how much? Minus 10?
Minus 20 probably.
Minus 20.
Still not enough for you.
Yeah.
So then we will go to something harder. For example, to the dry ice. Dry ice has temperature minus 40.
Okay. Sounds good.
And the advantage, it does not make... It consists of CO2. This very CO2 we are afraid of. And eventually, it evaporates to CO2 without any liquid.
Okay, what is it used for?
For example, if you want to carry ice cream, many years ago, my mom was ice cream seller, and she carried huge bag full of ice cream and this dried ice. No leaks, cool. So it's the main.
Okay,
application, I
main
guess.
usage. Yeah, okay. To keep other products or people cold. Sounded really bad. Eventually, if you want to kill someone.
Actually, there is a really bad story. One guy wanted to have really good party for birthday, and they actually splashed this dried ice over a swimming pool.
Yeah.
It made this fog and pushed out all the oxygen. Beware of liquid gases or solid gases, because when it evaporates, it pushes out all the air.
So
Safety
technically,
first.
yeah. Or if you want to have your last birthday, that may be an idea. I mean, we are responsible people. We let you choose. Everyone has the right to choose. There's democracy. Okay, yeah. So going back. Okay, that's another option. But it's not cool enough.
Only minus 40. And there is a better choice. There is the liquid nitrogen. Liquid nitrogen is already way below. It has temperature of minus 200 roughly. Minus 196.
96?
Roughly minus 200.
Okay.
And it's incredibly cold. The minimal temperature we can have minus 275. All the air here consists of 78% of nitrogen. So it's quite easy to get in compared to CO2, which is a bit more rare. So we can just get it, compress it properly, and eventually we have this liquid nitrogen. You probably have seen this in many, many shows where you probably
Yeah, this
cooking,
cloud, gastronomy, maybe also cocktails. Something. Science. We use it in science, by the way.
I guess it's
Because
heavily used in all the technical stuff where you have to cool something rapidly or where you have to cool something efficiently to low temperature, because minus 200 is... for example, when you cool down things, they are squeezing. Don't laugh.
You were speaking about...
So for technical purposes, for example, you want to place one metal thing into another one, and which have exactly the same radius. For this, you can make hotter one, but when you make hotter...
Yeah, because it's usually...
it's expanding.
Yeah.
But sometimes this part is made with some fancy thermal development, and you must not warm it up. For this case, you can simply cool down the second one, then it shrinks. You place it, probably with a hammer, and then it expands, and then nothing can like split them already.
Okay, yeah, so they are stick together. Well, that's a cool thing, and it's also surprising. And so many, and how many ways you can use it, right? Like coming like from health sector to science, and from science to gastronomy.
And science is crazily broadly used. For example, in my work, we have a special device which is called camera. It's roughly this camera, but it must be so sensitive. And when it's warm, you have thermal energy which throws out electrons from the sensor actually. But if you cool it down, it becomes more stable, low noise, high sensitivity, and we simply cool it down with liquid nitrogen. I just take a special bottle, actually thermocup, fill a couple of liters, pour it into camera daily.
Nice. Is it expensive?
It's actually not very expensive. I guess a ton of it's over 1,000 liters because the density of 0.8 roughly. So fewer than €1 per liter.
So maybe to order some.
But I guess when you order just a few liters, it's more expensive than if you buy a truck full of.
It sounds interesting, you know, when you come at your door, there's the truck with all of the
also,
bottles.
if you wanna probably rob a bank, you can freeze a wall and then break it.
Here we start already with how to get rich series. Yeah, but actually I remember you also were telling that you made an experiment at work, right?
We cooled down a log with the liquid nitrogen to check how fragile will it be. And first, we faced a problem how to heat it properly. When we found it, it wasn't really broken, just several scratches. And we tried it once more, this time keeping it in vise, not onto it. And this time we again weren't any close to break it.
Close enough, Sonia. Make it again, just vertical.
We tried again.
Okay. Well.
Over and over again.
Yeah.
It was the cheapest log I could find. Apparently the idea with nitrogen is a bit like from movie.
Yeah, okay.
With cucumber and
we will make a cut and I will show you experiment. How did we break a cucumber, frozen cucumber with a frozen banana, and who is harder? Who is winner?
which is?
What's your bet?
I think it is actually the banana because it still has the skin, right? The shell.
Okay, I will place and...
But yours?
Okay, then I choose cucumber.
Okay, for the
one of us must be loser.
Yes. And how do you measure it?
I'm doing physics. What do physicists do? On collider, for example, they have one particle, another particle, they collide them.
And that's
Fun.
it.
And we did it
like
with
the
cucumber.
speed of these pieces, the way they're like, would make it more complex.
and then we just spent an hour cleaning the table afterwards. Because it cracked in tiny pieces and distributed over the table. Indeed, everything was covered by those tiny sweet pieces. The experiment was totally professionally prepared. Cucumber, bananas, liquid nitrogen, and the hammer as a backup plan.
We have some bananas and a cucumber.
Obviously not enough. And now the second player kicks in.
Oh.
We did a preliminary check, and cucumber successfully
No, it's
stand
not so
against
crispy
a
as I
random
thought.
plant.
Okay.
And
Yeah,
then they finally met each other.
Sound test. Yeah.
And finally, an obvious winner.
Yes. I mean, we proved this. Like, it is possible to break bananas with cucumbers.
There were serious doubts.
Let's
And the
do.
loser had to be demolished.
Let's make
Brutally demolished. Yay!
Oh.
Violence! Sparta! You know, we also didn't let the winner to be free. Smash the flour with cucumber.
Oh, it's cracking too.
Be ready. Yes!
Wow.
But wait a second. Have you smashed the banana with cucumber?
Yes. Now we need more brute force. Okay.
Yes!
Oh my. Oh, it was half frozen. This is kind of disgusting actually, but yeah. Eee.
We tried to feed the remaining parts of food to the rabbits living nearby, but in 2 days we found out they also ignored this disgusting mixture.
tasty.
Also, there is medical treatments. For example, if you want to remove some, I don't know, what's marked
Yeah,
from
on the
skin.
skin. Yeah. It's more of the aesthetic, if you can call it. Yeah, because I've used this once. So I had the thingy, and I went, and actually it's kind of burning because of being that cold. So that's why I said also, like, for the health department or the health sector, that there it's also being used, and it's pretty common. They were being using like years and years ago.
People use liquid nitrogen really broadly because it's just not that expensive. Nitrogen is here. You have no problem with nitrogen.
What is the disadvantage of using it, for instance? Like, let's say it from the scientific part, right? Is it something that probably, I don't know, makes it to work it with more difficult?
It's easy. It's
easy.
So there is a next step I'm going to speak most of the time about. But here, everything is easy. It's easy, cheap. It's only not that cold. Only, so like minus 200. Basically, we physicists count not from Celsius. Like, what's frozen point of water? It's just nonsense. We count from zero. Zero is absolute zero. Temperature corresponds to like minimal temperature. If you remember, temperature is basically how fast the molecules are shaking, moving, and absence of motion is zero.
Yeah, so like the hotter it is, they're moving more,
they're moving faster, and
it's
no
more complex
motion is zero. And we count in temperature from this point. From this scale, so like step, the degree is the same from Celsius, but it just shifted. So liquid nitrogen has temperature of 77 or 70. I guess 77.
Okay. And you are saying right now that, okay, this one, the disadvantage is that you cannot use it maybe sometimes because it's not that cold. It means we have something colder.
Sure. And the winner is, absolute winner is liquid helium.
Oh, interesting. Is that gas that you're using to laugh? To change your voice?
Yeah. In those balloons.
Yeah.
But and the funniest part, it's second popular element in the universe. The universe consists of 75 persons of helium. 75. Just figure out how funnily you can speak in the universe. But for some reason on the Earth, this case is quite rare. Really rare. I guess when you do some, what's called, some geology in really deep mines, there are some places where it is. And therefore it's crazily expensive.
Okay.
Like a liter of liquid nitrogen is below €1 liter. But for liquid helium, it's about 10 or probably 20. I guess 2 years ago was a huge crisis of liquid helium. And I guess we ordered some from Poland just to deliver.
From Poland, that is surprising. Do they have their own distributor?
It was just somehow available there.
Oh, okay.
It was expensive, but available.
Okay. But okay, let's speak now like in comparison. Which is the difference of temperature here?
Liquid nitrogen has temperature of 70 or 77 Kelvin, and liquid helium has temperature 4 Kelvin. Just 4 Kelvin. 4 Kelvin, 4 degrees above absolute zero.
So that's considerable. Like that's a big difference between them.
And it was the last gas could be liquefied. I don't know. I guess hydrogen was liquefied but didn't have that low temperature. And helium was the last. Since it has that low temperature, it brought to huge opening, really new physics began. Quantum physics. Because quantum physics. The idea is all the quantum effects are really well seen in absence of heat. Because when you have quantum effect, some particles are flying, you also have some shaking of atoms and crystals, it spoils all the quantum mechanics. But when you have low temperature, you can have superconductivity.
What we were talking about.
Liquid helium.
Yeah.
Liquid helium is the coolest liquid you can get on the Earth.
But the most expensive.
The most expensive. The trick is quite rare as nitrogen is here around.
Yeah.
You can just
Collect
evaporate. You can evaporate it and you don't care if you lose it. Helium is rare. Therefore, if you use it, you have to collect it and bring it back. Otherwise, you will pay really a lot.
Yeah, that's true. And also, that makes sense why we cannot use it in other
applications.
To apply it to different sectors. Let's say if you want to use it in gastronomy or so on. I guess the other one.
But what's for you difference between minus 200 and minus 270? For most of the applications, you will not see any difference. But for quantum system, you will see. For quantum computer, you will see. It will not work even at 4 Kelvin.
So, like, technically, you don't need it somewhere else.
You don't need it. Simply, you don't need it. Minus 200 is enough for most of the things. It's always economical question at which point it's worth.
Okay.
And for example, even in study I was making, like, I was studying quantum dots, and even then, quantum system, for half of the applications, I could use liquid nitrogen. And only for some, I cooled it down to 4 Kelvin, where I needed exactly quantum behavior of the quantum system.
So yeah, like in general, you're also not using it that much because it's that expensive.
Yeah.
Only in needed.
Only when it's needed.
Okay. And other applications that you know of?
Mostly really deep science, but I have one good application.
Tell me.
Tomography. You know the tomograph?
Yeah.
This huge thing where you kind of this donut-like. And in this donut, what's inside? Did you ever think?
No.
Superconductor.
Okay, give me more details about it.
Superconductor, it makes a strong magnetic field. And in this strong magnetic field, you can use the effect which is called nuclear magnetic resonance. It is sensitive to water. And the magnetic field is made this way that the water responds from really tiny area. And how strong response is, from that you can recalculate how much water in this area. So therefore you can resolve where is your bone, where is your like other material.
Yeah, like organs and so on.
Yeah. That's the most popular application. And this donut is crazy cold inside.
Now it explains a lot why it is so expensive to make one.
Yeah.
Right. Also, for the health reasons, it's not good to repeat it and to make it like over and over again. But price-wise, it's pretty expensive. And now it makes sense.
Really, the topic of superconductor has begun with only liquid helium in 1908 or 1906.
96. Yeah.
1906.
06, yeah.
The helium was liquefied, and I will make a separate video about it and how it brought us to quantum computers. Liquid helium brought us to quantum computing.
And they're being used right now for that. Yeah.
And the question was like how the regular things behave at that low temperature, because it's almost zero. And people started to look how resistance behaves, and suddenly discovered superconductor. It has no resistance at all, just zero.
Okay.
Which is like super counterintuitive. Like you cannot walk with no resistance. You always have something, but there is no. And based on it is done quantum bit. But the trick, it does not work at 4 Kelvin. 4 Kelvin is not cold enough.
So it has to be a bit more?
You have to drop temperature. How? It's coolest liquid.
How do you drop the temperature then?
Another Nobel Prize.
You just received Nobel Prize.
We have kind of fixation on Nobel Prizes.
Yeah. But that's fun, because also like starting from it, you can see a lot of applications. And
First of all, guy who did it, Heike Kamerlingh-Onnes from Netherlands, when he discovered and did many basic experiments, he got Nobel Prize 5 years later, something like that. Then he discovered superconductivity, but quantum mechanics in 1913 did not exist. They had to wait 2 decades unless it's at least somehow explained. And Nobel Prize for Badin Cooper-Schrieffer, who did the theory. Then, some years later, I don't remember the years, but at some moment...
Somewhere here we're going to place the years.
Kapitsa did study...
Pizza.
Not pizza, Kapitsa.
From Romanian, ka means S. S pizza.
Please, all the people who understand Romanian, write in comments if the joke is funny or not.
If they say no, it means you didn't reach that level.
Sorry. So
Kapitsa.
He somehow figured out that if you lower pressure, temperature drops. For example, water boils at 100 degrees on the sea level.
Yeah.
But if you're in mountains, it boils already at 70, and you cannot boil eggs. Yeah, altitude. It probably, I don't know the history of science, but it probably, this idea was obvious, and they thought 4 Kelvin at sea level. Yeah. What if we reduce pressure and temperature dropped? 4 Kelvin was not limit. It dropped down to 1 Kelvin roughly. Plus minus 1 Kelvin. Just we have now roughly 300 and he has had 1. Quantum effects. Wow.
Damn.
For example, and the biggest catch here, that at 1 Kelvin the helium turns into superfluid state. It's kind of superconductive state, but superfluid. And in this state, it does not boil. And for me, it was the only reason I used it for some experiments. Because when you study some quantum system, you just place it in liquid helium, but it's boiling. And the bubbles are disturbing the beam you're shining.
Yeah, okay.
And then you simply cool it deeper. You just apply actually extra pump, which drops pressure. That's it. And then it's in superfluid state.
Interesting.
I never played with any properties of this superfluid thing. The only I needed a temperature, and it's not boiling. Very stupid, like, to use microscope as a hammer.
Oh my god. Yeah, well, that's surprisingly. So a lot of work being done, and still that's the beginning.
And he got Nobel Prize for this, definitely.
He could, he should. Yeah.
He deserved.
True. Yeah, that was the word. And also speaking about these liquid gases, like, can we try them, drink them, do something?
You better not.
Okay.
Actually, the safety is really... There is a lot about safety measures. For example, as for liquid gases, first of all, if it evaporates, 1 liter of liquid gas gives you 700 liters of gas. For some, they replace in air. So basically, we have 78% of nitrogen. Then we have 21% of oxygen, which we really need.
Yeah.
And if we have a lot of extra nitrogen, we have fewer oxygen. And I guess below a couple of percent, you will just fall asleep.
And the best case scenario?
In best case scenario, you will awake.
Well, they're usually 4 scenarios, right? Prisoner's dilemma. Best case, Nash equilibrium. Worst case. The fourth one.
The second thing, it's crazily cold. Liquid nitrogen you can touch. Probably we'll make an extra video where you touch liquid nitrogen. Or I will. We can.
I can come to your work just to say.
Just to touch it.
Yeah.
Liquid nitrogen.
Yes. But it's also dangerous because I'm pretty curious. Usually, what I go, someone's like, oh, what's that for? And then it can be that something breaks.
For which purpose is this red button?
Yeah. You can press it, in 3 seconds, boom. So yeah, probably you don't have this thing.
And the thing figure out the liquid nitrogen is boiling at room temperature because it has a temperature of minus 200, and when it's on the surface of 300 in the effect, it's like you have water on something with temperature of a few hundred, like on the frying pan, and it behaves exactly the same way, exactly. But liquid helium behaves differently.
Okay.
It's energy. So when it evaporates, it takes extra energy from surrounding, like from the surface, and evaporate. And helium needs really few amount of energy, and then it just turns into gas. So if you, for example, if you have reservoir full of liquid nitrogen and you place something hot inside, it's boiling. The mechanism is this: you place your, something, probably even finger inside, and first moments around this thing, a lot of gas occurs, and it kind of screens you from the contact with the liquid nitrogen. It's safe to have finger in liquid nitrogen for a second. 5 seconds I don't recommend. For 1 you can do. Even boiling water is more dangerous because it does not work this way. You will be immediately damaged.
Yeah, because actually there is not a gas, but it's liquid, right?
Yeah,
so
it immediately wraps you.
Yeah.
And liquid nitrogen does not. But liquid helium is not this. It will immediately explode because it has a really low energy, which needs to turn from liquid to gas. And if you do, it evaporates all, and you figure out 1 liter of this liquid helium or liquid nitrogen turns into 700 liters of gas. And the pressure rises immediately. We have had a case, so we use superconductive coils to keep magnetic field sometimes. If something went wrong, and this coil is inside of reservoir with liquid helium. And if something went wrong, really huge current, superconductive current turns into the regular current. And regular current always makes a lot of heat. And you have reservoir full of liquid helium, which starts to boil. And it evaporates that rapidly that all the tubes are freezing, really. They became super snowy. In the worst case, something can crack because at crazy low temperature, anything can happen because materials became really fragile.
Yeah, and if you touch it like also from exterior, maybe also can happen something.
Don't leak.
Okay, it's good to know.
With helium, it's way colder.
Yeah, but that's a really cool thing.
And probably the best score. The best score.
Till now.
Millikelvin. Millikelvin.
Amazing. So we have...
We cannot overcome this limit of 0, but we can be close and close. As far as I remember, there is even a theorem which forbids to have exactly 0.
But why would it be like that theorem?
Quantum mechanics. For example, in case of quantum mechanics, 0 Kelvin means no motion. And with no motion, if something does not move, you know simultaneously its position and momentum. 0, like position and 0 momentum. It's against of rules. I presume I do not know how this theorem works, but basically there is a forbid.
Oh, nice. That's
the coolest temperature is when you mix helium-3 and helium-4. Helium-3...
What's 3 and what's 4?
Inside of helium, you have 4 electrons. Sorry, inside of helium you have 2 electrons. And inside of core nucleus, you have 2 protons and 1 or 2 neutrons. It does not change much, but they are already not identical. And if you mix them, there is a crazy thing which is called entropy of mixture. And this entropy takes some temperature. And this way you cool down this system to millikelvin. I guess 0.1 or like units of millikelvins.
Yeah.
And at this really low temperature, you can study many quantum effects. For example, you can see excitons, which are known as artificial atoms.
Yes, we also spoke about that. Then you said about mixing them.
Yeah, you're mixing, and the temperature is dropping down because of fancy effect, which is called entropy of mixture. It's kind of, when you mix ethanol and water, I guess it gets warmer for some reason because of entropy of mixture. So on this effect, you can get this extra temperature and cool it down to really low.
Okay, so you can play with it in order to get the temperature you like or like you need in order to...
And what do people do if they need not 4 Kelvin, but 6 Kelvin?
What do they do?
They make a flow of helium and then extra heat the sample, and then at some moment you have thermal balance.
Oh.
Because they are limited quite.
I thought like it could be something, more complex.
Too stupid.
No,
too direct.
Yeah, the way it was that saying. So, like in simple things, there is the science, or how was it?
How many Nobel Prize did we mention today?
2.
I guess 3.
3?
For study of low temperatures, superconductivity, and superfluid liquid.
Yeah, you're right. 1 I missed.
Probably next time we'll try to merge really a lot.
Yeah, but it's actually I think this time we managed, right?
Last time we mentioned only 2.
Yeah. And but this time we had a lot of other applications, and starting from the fridge and coming to here, right?
And all was really applied.
Yeah.
Quantum computer, ice cream. It's all we need in our life.
Yeah, especially on a hot day.
Okay. I guess we have to remind you to subscribe us, to write in comments something, especially if you like her Romanian jokes.
Thumbs up. Yeah, subscribe, follow all the other social media pages.
I will place it
Yeah,
there.
here, somewhere. And yeah, give suggestions.
Yeah.
What to do better, what to change.
Where did we fail?
Yeah. Or what to improve. That's the positive thinking, right?
We need Oliver in comments.
Yeah, okay. So, thank you very much. I'll go and find some